So hopefully now we're ready to actually start doing some of the problems. So when you look at worksheet 511, because basically we're splitting what would have been unit 5 into 2 units. So we're going to have 5.1 and 5.2. So we're splitting the unit into 2 parts. So this is what worksheet 5.1 looks like. So you got the first set of problems, and these are all unit circle. That's the thing. That's why these are separated from worksheet 5.2, which we'll get to in another video. So 5.1, you're looking at and you're saying, okay, oh, these are all unit circle. The inverse, when does sine, I should have put a does not exist on here. But anyway, if you had this question, you got to read it as what angle has a sine of 0? And you say, okay, based on my restrictions that we talked about, which I should have that more prepared, you'd say, oh, that's easy. Okay, so we're basing it all on our restrictions. So inverse sine of it, well, I don't know. Where does 0, when is sine equal to 0? Well, sine is equal to 0 at 0. What angle has a secant of 2 root 3 over 3? Well, let me see. That's when cosine is equal to root 3 over 2. Well, that happens at the pi over 6s, and it's first quadrant, so it stays positive. When does cosecant get the 2 root 3 over 3? Well, that's when sine is equal to root 3 over 2. And oh, when does sine equal root 3 over 2? Well, that's at the pi over 3s, the 60s. But it's negative, so that means we have to do the negative fourth the negative reference angle. Just like our rule here, it was negative, so we do the negative reference angle. When does tan, let me see, when tan and cotan are equal to 1 at the pi over 4s, but it's negative, so we got to go with the negative there. It's negative, so we do the negative reference. Cotan, when does cotan get the root 3 over 3? Well, that happens at the 60s, which is the pi over 3s, but cotan would be in the second quadrant, so that would be 2 pi over 3. When does cosine equal to negative 1/2? There's never a time when, cosecant, there's never an angle when cosecant's equal to 1/2. I just thought of something else I should have added on here, but I'll come back. If I think about it, I'll come back to it. Now you got all these problems right here, which are multiple steps. So we got to think in terms of do the inside first. So you'd say, okay, when does cosecant equal to negative 2 root 3 over 3? Okay, well, that happens at cosecant 2 root 3 over 3. So that's going to be a pi over 3 because it's just like this one here, but it's negative, so fourth quadrant. Now we've got secant of negative pi over 3. Well, secant equals to secant at the pi over 3s, the 60s, is 2, and negative pi over 3 is the fourth quadrant, and secant in the fourth quadrant is positive. Like here, you say, okay, when does cosecant, arc means inverse, got to emphasize that. When does cosecant equal to negative 1? Well, that happens at negative pi over 2. It's not 3 pi over 2, even though it wouldn't actually affect this problem because of our negative pi over 2 to pi over 2. So then we've got, what's the cotan of negative pi over 2? So cotan of negative pi over 2, so that would be 0, negative 1. So cotan is x over y. So that's 0. When does cosine? Oh, no. Oh, so now we've kind of flipped the order. What's the cosine of pi over 3? Well, cosine of pi over 3 is 1/2. So then what's the inverse sine? What angle has a sine of 1/2? Well, that's pi over 6. Let me see. Tangent 5 pi over 4. 5 pi over 4, that's what quadrant? Third quadrant. Pi over 4, so that would be positive 1. So this is actually okay, what angle has a secant of +1? Well, that's 0. Let me see. Now, here's going to be the temptation on a problem like this. Oh, look, inverse sine and sine just cancel each other out. Unfortunately, it's not that easy because of the restrictions. You'd have to say, what is sine of 5 pi over 3? Oh, well, that is negative √3 over 2 because that's fourth quadrant. And then you say, okay, what angle has a sine of negative √3 over 2? Oh, fourth quadrant, we have to say negative pi over 3. So see, it wasn't just a straight up cancelization. Because of the restriction on the inverse sine, we had to go with the negative reference angle. Similarly, on this one, what's the cosine of 5 pi over 4? Oh no, 5 pi over 4, that's third quadrant. So in the third quadrant, cosine would be negative. So now what's the inverse cosine? So inverse cosine, what angle has a cosine of negative √3 over 2, or negative √2 over 2? Well, let me see, that's a pi over 4, no doubt. And it's negative, so it's second quadrant, so 3 pi over 4. Point being, once again, it wasn't just a straight up cancel problem. Similarly over here, see this one actually does straight up cancel, because what's the secant of pi over 6? Well, that's 2 √3 over 3. And then arc secant, what angle? What angle has a secant of 2 √3 over 3? Well, that is pi over 6. So see, that one did just straight up cancel, but we can't just rely on that because there are all these cases where it doesn't, like cotan of 11 pi over 6. Well, that's going to be negative √3. But then when I do arc cotan, I'm going to say, all right, what's the inverse? What angle has a cotan of negative √3? Well, let me see. Cotan gets the √3s at pi over 6. But it's cotan of a negative, and cotan of a negative goes into the second quadrant, so 5 pi over 6. So anyway, that's what you have to look at when you do the problems from worksheet 5.1.